Hi, Assalamualaikum. So we are from Group 9. We will present about our case study 2. So in case study 1, we studied the immobilized cellulose for bioethanol production. In case study 2, we will evaluate its societal, health, safety, legal and cultural impact and determine the technology readiness level, which is, or we call it as TRL. So this assessment integrates with technical feasibility with public perception and professional ethics. So the immobilized cellulose system is currently at TRL 4 until 5, which the laboratory scale experiment demonstrated effective hydrolysis and glucose production. So the pilot scale studies using 20-liter reactor confirm that the system can operate effectively with magnetic recovery. However, full industrial deployment has not been yet achieved. So which is the consistent with TRL 4 until 5 criteria. So the key advantage of this system is the ability to recover and reuse enzyme, reducing the operational costs and supporting the continuous processing. So this TRL assessment helps us in identify the next steps needed for scaling and commercialization. So in case study 1, the cellulose enzyme were immobilized on iron oxide magnetic nanoparticles using glutaraldehyde. So this allows enzyme to be separated from the hydrolyzed after hydrolysis and reused for multiple cycles. So this process improves the operational stability, reduces enzyme loss, and lower the overall cost. So from a biochemical engineering perspective, the immobilization converts a batch dependent enzymatic step into a more stable. So the reusable catalytic system suitable for continuous or semi-continuous operation.
Next, I will present the result of the public survey on the biocatalyst technology for bioethanol production. This survey was conducted by using the Google form and involved about 147 respondents. The purpose of this survey was to evaluate the public awareness, acceptance, and perception of the immobilized enzyme technology for the converting agriculture waste into the bioethanol, which is a renewable fuel. Based on the result, around 34% of the respondents were moderately or very familiar with the enzyme-based industrial technologies, while 12.9% consider that themselves are experts. This indicates that although some respondents have knowledge about the enzyme technology, but public awareness is still limited. However, the overall acceptance was positive. About 44.9% of the respondents agree or strongly agree with the use of the enzyme technology for the bioethanol production. In addition, about 29.9% are remain neutral, while only 25.1% are disagree. Uh, Although some respondents remain the neutral, but this result suggests that the public generally has a positive attitude toward the technology. Next, the survey also investigate that the public perception of health and safety. Only 27.2% of respondents believe that the enzyme-based bioethanol production could pose the health risk, while 51.1% consider that the enzyme-based process to be safer or much safer than than the conventional chemical catalyst. The result also show that the respondent believe that safety measure and government monitoring are important. Approximately 47.6% agree that the existing safety measures are sufficient, and a similar percent this and a similar percentage support that the strict monitoring by authorities. Furthermore, about 41.5% of the respondents prefer natural enzyme over the chemical catalyst, showing a preference for more sustainable and environmentally friendly technologies. Overall, the survey indicate that the public generally support the immobilized enzyme technology for bioethanol production. However, further public education, proper safety regulation, and environment monitoring are important to increase the public confidence and support the future implementation of this technology.
Assalamualaikum warahmatullahi wabarakatuh. As part of my case study, I personally conducted an interview with Puan Nurul Atira binti Mokidin, a chemical head risk assessor CHRA from Nisepti Konsultasi, to obtain a professional perspective on the implementations of immobilized cellulose for bioethanol productions. So before starting the interview, I briefly explained that immobilized cellulose is a technology where a cellulose enzyme are attached to a support material, allowing them to be reused during the conversion of cellulose into a fermentable sugars for bioethanol productions. So this technology improves enzyme stability, reduce operating costs, and support more sustainable biofuel productions. So based on the interview, Puan Nurul Atira highlighted that before commercial implementation, the technology should undergo a pilot scale testing, which is hazard studies, emergency planning, and long-term stability validation to ensure safe and reliable operations. She also explained that immobilized cellulose can improve public confidence because it promotes cleaner productions, reduce waste, and enable enzyme reuse. So from a health perspective, although the process operates under milder conditions than conventional chemical process, workers should still wear appropriate PPE since enzyme exposure may cause allergic reactions. So in terms of industrial safety, the main risks are associated with bioethanol productions, including fire, explosions, equipment failure, and process instability. So therefore, effective safety system, regular maintenance, and operator training are essential. She further emphasized that bioethanol plants should comply with the Occupational Safety and Health Act 2022, the Environmental Quality Act 1974, and requirements of DOSH and DOE. And finally, she stressed that engineers must always prioritize workers' safety, public health, environmental protection, and ethical responsibility when implementing new technologies. So this is the conversation of me and Puan Atira from Nisepti. We conduct the interview through WhatsApp. So to conclude on what she mentioned, thus from industrial perspective, she agreed that immobilized cellulose has strong potential for sustainable bioethanol productions, provide that comprehensive safety assessments, regulatory compliance, and responsible engineering practices are implemented before commercial scale adoption.
Based on our finding, we have three main recommendations for the future development of this technology. First, the process should be scaled up from pilot scale to industrial scale using a stirred tank reactor integrated with magnetic enzyme recovery. This allows the immobilized cellulose to be separated easily and used, reducing enzyme consumption and lowering operating costs. Secondly, enzyme stability and performance should be continuously monitored throughout repeated operating cycle This is important because enzyme activity may gradually decrease after multiple use, affecting the efficiency of bioethanol production. Finally, public engagement. Public engagement should continue through awareness program and transparent communication. Although our survey show positive acceptance, maintaining public trust is essential for successful commercialization. In conclusion, immobilized cellulose is a promising technology for sustainable bioethanol production. It is currently at technology readiness level 4 to 5, demonstrating strong technical feasibility at the pilot scale. Our survey also indicate positive public perception, while safety, legal and cultural consideration have been carefully evaluated. With proper scale-up strategy and continue public engagement, this technology has strong potential for future industrial implementation.